Hey, welcome to the channel. Now we are going to discuss about different types of wrapper classes available in Java. So why do we have those? What are the different differences between these wrapper classes and which one to use at which scenarios, right? So although we have different classes available, we cannot use only one data type or one class across the project or in the practical scenarios. They're created for a purpose. So let's get started. So now we are going to discuss why do we have these wrapper classes. So what are we going to achieve by having the wrapper classes, right? So before we even talk about the wrapper classes, let's jump into the Java documentation and let's have a look at the primitive data types. Okay, so I have the official Java documentation open, and I'm referring here JDK version 8, the Java development kit. And if you see here, if you see the primitive data types and their description, although we have all the descriptions available for different data types, let's look at the interesting thing is here the float and the double. So if you look at the primitive data types, and here we're discussing about the float data type is 32-bit. And if you see here, the recommendation, as with the recommendation for byte and the short, use float if you need to save memory in large byte arrays of floating numbers. This data type, yeah. So if you look at it here, if you need to save memory in large arrays of floating point numbers, you have to use float instead of the double. And it is also said that this data type should never be used for precise values such as currency, right? So the Java documentation itself asks us not to use the primitive data types or float in particular for the precise values like currency, right? So this is very common in most of the scenarios like wallet, or in the banking applications, or for that matter anything which requires high precision, right? Any engineering related or industrial related programs. For that you will need to use the math java.math.bigdecimal class instead. Numbers and strings cover the big decimal and other useful classes provided by the Java platform, right? So if we jump back to our presentation, right? And so we see that we have the primitive data types available with Java to facilitate other developers to have a ease of programming with Java when they get started. But once they learn the concepts and the basics of the Java, so they should always move to the wrapper classes, right? So let us have a look at the wrapper classes documentation by Java. So if you look at the numbers class, right? So because the wrapper classes are nothing but the number class, all the classes such as byte, double, float, integer. So all these classes are subclasses of the abstract class called number class. So if you look at it here, right? So there are, however, reasons to use objects in place of primitives. Again, these reasons are because of the OOPS system of Java. So the object-oriented programming system of Java. And if you look at it here, the classes wrap the primitive in an object, right? So these wrapper classes are nothing but the primitive values which are wrapped around an object to provide the object functionality. So along with that, we also have different types of um, additional benefits which we can leverage as part of the implementation or the JDK implementation, the Java API. So here we can see the classes which are belong directly to the number class, the subclasses: byte, integer, double, short, float, and long. Along with that, we also have four other classes such as big decimal, big integer, atomic integer, and atomic long. And these are primarily used for the multi-threaded applications. For the scope, we are just talking about the big decimal. And you can see there are different methods which are available, which are under the abstract implementation of the number class. And we are going to discuss these values in detail, right? Okay, so let's jump back. So why do we need the wrapper classes? We already discussed about it. So double and float are created as wrapper classes to the primitive data types, which is already available, like double and float. which is in Java, and these classes are available from JDK version 1. Okay, so the main objective is to have the compliance with the OOPS concepts, and it is okay for the beginner developers to use these primitive data types, but wherever possible it has to be used, the objects has to be used, because it has multiple benefits, like you can handle exception handling, and you can also convert the object from one data type to another data type, right? And why do you want to do all by yourself when it is already provided in the Java API, right? So the other benefits of using the wrapper classes is by using these constants. So whenever we want to have the maximum value and minimum value, right? Such as, let's take a scenario where you want to generate a random number and you wanted to generate a random number between uh, number A and number B. So if you want that values to be between the maximum and the maximum possible randomness. So if you want to do it between the minimum value and the maximum value available for that particular variable, which is such as integer minimum value or integer maximum value. So you can use the static variables available across the wrapper classes directly in your code. And the biggest benefit by using the wrapper classes is you can convert to and from other primitive types, strings and number systems, right? So you can convert a short value into a double value, whereas the double value into a short value, provided you handle the exceptions. But this is a possibility, you can do that without having any additional code. This is provided to you by default. Whereas on the other hand, as we look through the documentation, we are going to discuss in detail about the big decimal, but the summary of that is, big decimal is created for high precision calculations, right? So you want to do any currency related calculations or any mathematical calculations which require high precision, you should use big decimal, as even the Java official team asks us to use the big decimal. All of the numeric classes are subclasses of the abstract class number. Although in the documentation we see there are only 8 classes, but even the big decimal, big integer, atomic long, and the atomic integer are the direct subclasses of the number, but they haven't showed it over there. And when we use the wrapper classes, we get the benefit of auto boxing and unboxing, right? These are the this is of why we need these classes. Why should we not use the primitive data types across our code? So let's jump in detail about what are these different classes, or what are the different implementations available, right? What are the advantages? So let's talk about float. So as we already seen, it is a direct subclass of number. Again, number is a abstract class which doesn't have the complete implementations, which do have some implementations available. And by using float, you can do the auto boxing and unboxing, right? So you can take a single value. We're going to again see this in the code in action of what exactly happens between the auto boxing and unboxing. So here you can take the primitive value and convert it into a wrapper class without any additional piece of code, right? And again, it's 4-byte 32-bit size, and generics doesn't allow you to use any primitive data types. It has to be an object, right? So whenever you are doing a generic programming in the collections interface, you need to use an object, and especially if you want to allow only floats or any allow only doubles, in that scenario you need to use these wrapper classes. So this is a must have thing as you progress through the project or the code. But instead of doing at that time, you can have the habit or a practice to implement wrapper classes as part of your base code. And again, it's useful for multi-threading if you're using objects. So you can have, if you know the multi-threading concept, so you can use it in multi-threading at multiple scenarios, right? You can serialize the objects, you can synchronize those objects. So there are different benefits, and this is available as part of the Java lang package, so you don't need to import any different packages for this. You can leverage the base package which is available. You don't need to have any additional import statements or get any third-party library. So if you look at again double, again it's a it is the parent belongs to the abstract class number, And again, it also does the same auto boxing and unboxing concept since it belongs to the same wrapper class family. Again, it's an 8 byte or 64-bit in size, this pretty big, and you need to decide in between whenever you're using between the float and the double. If you want to save memory, you need to use float instead of double if you don't think you're going to have such a big number. And again, it's useful for generics programming, and it's useful for multi-threading, and it is also part of the base java.lang package. You don't need to import anything. But if you see the right side, so these are the list of methods or behaviors which are available as part of the class, which we can leverage. So we can convert a double to a byte value or a short value, which is just simple method call. And if you see, the return types of those methods are primitive data types, right? So you essentially use these methods to display an output of a value, or you use it as an input of another class. So you get the returns as a primitive data types, right? It's not an object. And again, we have few functional methods like compare to, you can compare between different data types like different wrapper classes. So it might be the comparing a double to a byte value, or comparing double to a double, or comparing double to an integer, right? And you can also have the overloaded equals method. So every class has its own overloaded equals method which can compare between another double object to check the value equals, right? So comparing two objects as an equals might quite a challenging task. You don't want to compare the objects itself, but you want to compare the values within those objects. So that implementation is already provided for you within the equals method. So let's look at BigDecimal. Again, it's an abstract subclass of the abstract class number, and it is used in the high precision calculations. Use cases include currency and engineering calculations, provides different rounding modes. We are going to see it in action of what are different rounding modes available. And it is recommended by the official Java team if you are handling the high precision calculations. And this is a 32 byte space. It takes a 32 byte space, which is quite high, but it provides you the so many benefits when you're going with the high precision calculations, where size doesn't matter because nowadays RAMs are pretty cheap. And when we're talking about the high precision calculations, this is a must. Again, the one of the advantage of BigDecimal is that if there is a non-terminating decimal expansion, you can always handle that with an arithmetic exception. You cannot do this with the other classes. You need to write again custom piece of code. Why reinvent the wheel, right? So if you take an example, 1 divided by 3, you get 0.3333, and it's a non-terminating decimal. So if you don't expect these sort of decimals as part of your code or as part of your calculation, you can always catch that using an arithmetic exception. So you have an option or a high control along with BigDecimal, and which is must for the high precision. So let's jump back to the code and then let's see some code in action. So I have a simple Java project. So it's a simple Java project with JDK 8, and I'm using IntelliJ for the demo. So I'm creating a class. Let's say that wrapper classes. I have a simple Java class. Let's create a main method. So I'm going to take few values here. Let's say I have a variable integers. Let me declare it in one line. So I have an integer 8, integer a equal to 1, b equal to 8, and then I have few floats, whereas float c equal to, let's take a value 0.01, and d equal to 0.03, right? And I also take float total. I'm going to show you why I'm going to why I'm taking these variables. So I have a few variables here, 2 integers and 3 floats. So let's do one thing. So let's calculate, let's have a look at how division works, right? So how division going to behave in these different wrapper classes. So let's say I have a big decimal. Let me call this a big decimal equal to new big decimal of a. Mm, let me copy that, and I have a big decimal b, right? And then let me create two double equal to no double. Okay, I don't need to create an object here. I can simply use the unboxing concept. So I can typecast the value, integer value, to a double, and I can create another variable just by changing these. And let's also create a float values, right? So a float equal to float. Again, I typecasted the variable to this. Again, I need to create just another variable called float b. Okay, so I have all my variables. So two big decimals, two double, and two float objects, right? So let me just print out. So this is the output from let's say float divide, right? A by b, let's say a divided by b, and this is a float class, and then I just say a divided by b. Oh, sorry, my bad. So I need to divide with the variables of float. So a float divided by b float. Let me duplicate this, and a by b double. Okay. A double divided by b double, right? And then let's say big decimal. So one thing we should notice here is that big decimal has its own overloaded methods of double, add, subtract, and the multiplication. So here we need to do a big decimal dot divide, and then we need to give the b decimal. And also, if you see, there are several overloaded methods. So we have the scale and the rounding mode. So let's have a look at the scale. So let's say that I need a scale of 4, and I need a rounding mode of, let's say, unnecessary, right? So I'm going to explain you what are these different rounding modes, and then just run the application. Let's see the output. Okay. So if you just see the output, so a by b float is 0.125 and double is also 0.125 as expected. And then if you see the big decimal, it's 0.125, right? And let's say if I bring the scale down to 2, so here you're expecting only 2 digits to come up, so which has to be essentially 0.13. But if I just run the code now, if I just rerun the code, and it's going to throw an arithmetic exception, right? So it says the rounding is unnecessary. So by default, the rounding is half up. So half up is also called as the banking mode. So uh, it's simple. It goes to the nearest. So the default is the half even. It's also called as a banking mode rounding. So if you are having a value of 5.5, which has to be round to the nearest even integer, so which is 6, and then if you have 1.5, it has to be rounded to 2, and then if you have 2.5, in that case it will be rounded back to 2. So it goes to the nearest integer when the value of the decimal is between the two digits, which is equidistant from two digits. So 2.5 is equal to zero point 0.5 difference between the 2 and the 3. So in that case it going to pick the even integer, right? So here we said that there is no rounding mode necessary. But in this case, we are having 3 digits, right? The minimum we have is 0.125, 3 digits. And we are saying that the scale is nothing but how many digits we are going to have. We are expecting in the output. So let's say that I'm expecting only 2 digits in the output. In this case, there has to be a rounding which has to be done to 0.13 or 0.12. So let's say that if I say that the rounding mode is half even, and if I rerun the, and if you can see, since it is equal to 0.125 is equal to 25 is equal to 3, and 2 in between, in that case it is going to pick up the even value. So in this case it's 0.12, and if I going to say half up, so in this case we should be expecting 0.13 to come up, right? Yeah, we can see that it's 0.13. And when we say unnecessary, it says that, okay, I'm going to know, I know what is the number of digits after decimal my division should perform and get out with, right? And then you don't need to do any rounding. In this case, we are having a 3 digits and the output expected is 2 digits, which is a conflict, and float and double goes well with it. And whereas in BigDecimal we have the option to control and catch the exception and whenever and take necessary action, right? So in this case I'm just going to change to 4 and just run the application. So we get 0.1250, right? So we need 4 digits after decimal, and which is exactly is what happened. Now let's see where else we are going to see the differences between the BigDecimal and the other data types, right? So other wrapper classes. Okay, so let me create 2 more variables. So I'm going to duplicate this. Let me create C BigDecimal and D BigDecimal. So in this case, I'm going to send 0.01, and because BigDecimal asks us to send the values either in strings or in integers, it doesn't take from other floats or doubles. And BigDecimal is a decimal system. Again, it's a base 10 system. It doesn't convert the values we send into binary and then store in the system. Although finally it does store in the system as binaries, but it will take the values as the decimal system. Whereas in double and the float, they are stored finally as the binaries and then even retrieved as the binaries. So we are going to see that difference now. Okay, so I have C double and B double, I have C and D, C float and D float, I have C and D float. But again, float is unnecessary over here because the values itself are floats, right? So let's duplicate this entire thing. Let us say A minus B float, A minus B double, it has to be d minus c, d minus c. We're going to find the difference between 0.003 and 0.01. So let's change this, d double minus c double, right? Again, we need to remove that ambiguity. Okay, and d float minus c float, and we're going to remove this and say d big decimal subtract c big decimal, right? Right. Let's run this code and see what is going to be our output. Right, if you see the output, although the values, right, so let us go back and look at the values here. So the value of c is 0.01 and the d is 0.03, right? And if you see the float difference between the d and c variables is, although it is 0.02, the value in the output is 0.0119, right? 199, and it's a trailing list. So although this is an exact value, so which is quite simple, right? So but since these values are stored in the underlying system as binaries and calculated as binaries across the across the subtraction and the addition, right? So these errors are occur. So this is the reason Java recommends us not to use the float and the double as the main classes while doing the calculations, high precision calculations. Whereas if you see the big decimal, even the C big decimal has 0.01 and D big decimal has 0.02. The final value which we get as an output, sorry, it is a typo, and let's run the application again. Right, so if you see the output right there, the big decimal difference between the C and the D and the C is 0.02, right? Straight out of the box. Again, you don't need to do any rounding or any such thing. The calculation itself is perfect. We can also see that the double values are also correct, 0.02. Let us take another scenario of where that might fail. So I have a float total variable here where I have only 0 as a base value. So what I'm going to do now, let me also take another big decimal. Let's say big decimal total. So what I'm going to do now is I'll create a simple for loop, and then let's say int I equal to 0, I less than 100, and I plus plus, which is simple code, and I'm going to say float total plus equal to 0. Right, so I'm in every iteration I'm going to add 0.2 as the to the previous value and assign it as a current value. So in every iteration float total is going to increment 0.2, so which has to be when we finally get that, it has to be 20. The value has to be 20. Let's do the same thing with so let's rename bd total. So what I'll do is I'll do the same thing for the big decimal. So since it's an object, I don't have an unary operator like float. Let's do this, bd total equal to bd total plus, okay, so I'll also create another seed value variable since I cannot add a value directly to the, let's say, seed value, and I'll say 0.2, and I'll start this value with 0. right? So I have a big decimal of starting value as 0, and I have a seed value of 0.02, or let's say 0.2. In this case, I'm saying BD total plus seed value. Right? So I'm going to assign the, oh sorry, I'm going to need to use the add functionality and send the big decimal as the value. And then let's say float total. And big decimal total. Right? So let's differentiate between those. So this section is total and this section is subtraction, and this is division, right? So let's run this code and then see the output, right? Right. So if you see the total output, the float, although it has to be, it is iterated for 10, 100 times, and then the final output has to be 20, you can see that the final output consists of even different value, right? So which is dot 4 zeros and 5 zeros and 4. Whereas the big decimal total is exactly perfect, which is exactly 20. So this demo actually shows that why should we use float, big decimal instead of float and double, because this is not built for the high precision. Although it is evident that big decimal, if you're using creating an algorithm and you're trying to use big decimal as part of it, this is going to affect your performance of the algorithm, because big decimal has its own addition, subtraction, all the mathematical operators, overloaded methods, which does take some time to perform compared to double and float, which is a binary operator, right? And big decimal also takes larger space of around 32 bytes, and if we are not using in algorithms, this is not going to be a big performance difference compared to what benefits we will get out of it, especially with the precision. So this is exactly is what the difference between the double and the float values, right? So let's have a look at of what else are being given as part of the big decimal, right? So again, we have already discussed about these big decimals, high precision calculations and all those. So if you see the class hierarchy, we have seen already in the documentation that there are around 6 classes which have been shown, but there are also 4 other classes. So here I also added big decimal to again reiterate that this also belongs to the number superclass. Again, the summary of the entire summary of the entire differences between the big decimal, double, and the float. Big decimal is 32 byte, double is 16 byte, and float is 8 byte. Again, big decimal uses the decimal system compared to the double and float, which uses the binary. And big decimal is high precision, and double and float are low precision. Again, comparatively between all these three, big decimal does slow the actual operations. Uh, it is very minuscule. You don't need to worry about if you're using it for the regular calculations. Whereas if you're using it for creating algorithms and in between those, you need to be worried about. whereas double and float are fast. And BigDecimal is available from JDK 1.5. It is also available before JDK 1.5, but not with the all the improvements and the functionalities which is available right now. But again, if you are using JDK 8, this doesn't make any sense. But BigDecimal should be aware of it, right? So BigDecimal uses before JDK 1.5, after JDK 1.5, and double and float are available from JDK 1, right? Again, this is the wrapper classes are created from right from the start, to port the developers or the programmers from the primitive data types to the wrapper classes. Whereas the BigDecimal, again, it's a later edition, as in fix for all the double and float, the gaps for the double and float. Again, which should we use, which is better, or which should we use? Again, this is not a single rule of thumb that we should use BigDecimal across all places. Again, you know that BigDecimal is only for the use cases like currency and engineering and industrial calculations where precision matters. And again, it does slow the algorithmic speed, and whereas double and float can be used as at every other places where you don't see that precision as a big difference or an big problem. And the primitive classes at all cases should be avoided and replaced with the wrapper classes, right? It will facilitate the future scope of your project, because double and float are only created to make sure that you get started with Java. But once you're moved out of that beginner phase, since you know the benefits of the object oriented language programming system, right? So you should always try to avoid the primitive data types, and you should always use the wrapper classes. I think this helped with you in terms of understanding the different wrapper classes available and the advantages of the BigDecimal across the double and float. I personally used for so many years the double and float, whereas I hit a roadblock during the currency calculations, where I was operating between the decimals, minute decimals like 0.012 and 0.013. And then I started realizing the differences of why this is acting weird. And then when I went through the documentation, I discovered the BigDecimal class, which is a savior for me. I think it hopes it will give you a different perspective or the view of why should we use. And there is a class like BigDecimal which is actually solve these problems. If you like this video, give a thumbs up, and then please do subscribe, and to know the more upcoming videos, interesting videos. And you can also let us know in the comment sections of what different concepts you're looking for me to make videos on, and which is helpful for all, right? So I would like to end my video with a um, with an inspirational quote which actually helps me, the random quotes which actually help me through my daily life to get going with what I do, to improve myself. So again, this is from Roosevelt: nothing worth having comes easy, right? So if you wanted to do something great, it doesn't come that easy. You need to struggle hard for that. You need to do hard work for that. So if you're already doing hard work, don't get discouraged by yourself. You're doing great, and then there's something great coming on your way. Be consistent, be persistent about it, and you're going to make big. Thank you.